Have you ever stopped to think about how data actually moves around inside your favorite apps? Well, it turns out it's a lot like traffic in a super busy city. And without rules, you'd have total, absolute chaos. So today, we're going to dive into the official traffic rules for data, the Reactive Streams Specification.
I mean, just picture it. A city with zero traffic rules. It would be a complete nightmare, right? You'd have cars just ignoring signals, gridlock everywhere, accidents piling up. But now, flip that on its head and imagine a smart city where everyone follows the same, clear rules. The traffic just flows, everything is smooth, and the roads are safe. This exact same contrast, we see it play out in the world of software all the time.
See, the thing is, in any complex system, you've got data flowing constantly between all these different parts, and they're often moving at wildly different speeds. So without any rules, a really fast component can just flood a slower one, causing what you could call digital accidents. I'm talking memory overflows, system-wide crashes, the whole shebang. And that's exactly why we need a universal rulebook.
Okay, so to really get a handle on these rules, we first need to meet the key players out there on our digital highway. Let's map out who's who in this little smart city of ours. All right, let's break this down. The vehicles, the actual cars on the road, that's our publisher. They're the source, the ones creating this whole stream of data. The roads themselves, that's a subscriber, the destination that's taking in all that traffic. The subscription is the absolute crucial part. It's the signal control system that manages the entire flow. And then finally, you've got the processor. Think of it like a big highway junction. It's both receiving traffic and sending it off in a new direction.
Now that we know who's on the road, let's zoom in on the most important piece of this whole puzzle, the traffic signal system that prevents all that chaos we talked about.
This whole system is built around one incredibly powerful idea called backpressure. Traditionally, a lot of systems just push data. The source just sends stuff out, kind of hoping the other end can keep up. Backpressure flips that script completely. It's a pull model, where the destination, our road, the subscriber, gets to tell the source exactly how much traffic it's ready for. This one simple change is an absolute game changer for preventing system overload.
This right here, this is the fundamental contract. The subscriber says, hey, I've got room for 10 items. And the publisher sends, you guessed it, exactly 10. Not 9, not 11. This simple, powerful agreement is the heart of what makes these systems so stable and so resilient. It makes it pretty much impossible for the recipient to get overwhelmed.
Now, what's so cool about this is how the entire conversation is handled with just 3 signals. Seriously, think of them as traffic lights. onNext is the green light. Hey, a piece of data got here safe and sound. onError is like a huge accident report. Something went wrong and all traffic on this route stops, period. And onComplete is that you have reached your destination signal. The data stream is done, the journey is over.
And the specification is incredibly strict about this. Once an error is flagged or the stream is marked as complete, that conversation is over. No more data, ever. This strictness is what makes the system so predictable and safe. You never have to worry about a stray piece of data showing up after you thought things were finished. There are no surprises.
Okay, so we've got the players and the rules for a single interaction. But for a whole city, a whole ecosystem to function, it's absolutely critical that everyone is following the exact same rules. Let's dig into why that is. Just take a second and really think about it. What would actually happen in a real city if every single driver just made up their own interpretation of what a red light means? Yeah, it would be pure chaos. And it's the exact same story in software. If different libraries didn't agree on what onNext or onError really means, they just couldn't talk to each other. Systems would become incredibly fragile, and they'd break the second you put them under any real pressure. The whole digital city would collapse. And this is why the Reactive Streams Specification is so incredibly important. It's not a library or a framework you download. It's a standard. It's a universal language that makes sure everyone is playing by the same rules, which allows all these different pieces of software to work together perfectly.
And this just shows you the real power of that standard. You've got these major, heavy-hitting frameworks like Spring Webflux, RxJava, and Akka Streams. They're all built by different people for different reasons, but they all speak this one common language. That means they can all work together seamlessly. It's awesome.
So we have this really elegant technical standard that everybody follows. That's great. But what does that actually mean for the apps and services that we depend on every single day?
Well, the payoff is huge. It means our systems are just fundamentally more stable.
Backpressure isn't some nice-to-have feature. It's guaranteed. And that lets these systems handle enormous, and I mean enormous volumes of data without ever breaking a sweat, which is absolutely essential for the modern internet.
And you see the results of this technology everywhere. This is the stuff that powers some of the most demanding applications you can think of, from the high-speed transaction systems that major banks, to the streaming services you use to binge-watch shows, all the way to the real-time dashboards that businesses use to make split-second decisions.
So, at the end of the day, the metaphor just holds up perfectly. Just like a clear, universal set of traffic rules lets a massive city function safely and efficiently, the Reactive Streams Specification provides those essential rules that keep our entire digital world flowing smoothly without crashing and burning.
It's a pretty powerful idea when you think about it. And it kind of makes you wonder, as our digital world gets more and more complex, what other areas out there are just crying out for their own universal set of traffic rules?